Okay, now if you remember, I said we have a element. Okay, let me go back to my red. That was my default color whenever I explain something. So we had our element, right? And I said each element is made up of 6.022 e to the 23rd atoms. Okay, an element is not same as an atom. Okay, atoms, right? Okay, every atom is made up of protons, electrons, and neutrons. Okay, so we only have to work with a single atom, and then the element automatically, you assume, will make photocopies of whatever was in that one atom's identity. Okay, so we don't need to do it for that many. And we learned how we calculate how many protons and electrons and neutrons exist in an element in a ground state. That's very important. We are not talking about ions yet, okay, probably down the road, but we're primarily talking about an element in a ground state as you look at it in a periodic table. And whatever we learn in terms of number of protons, electrons, and neutrons, only applicable to an element in a ground state. Okay, now if you don't hear me say the word ion, by default I'm referring to a ground state element. Okay, every element is made up of that many atoms, and every atom contains a certain number of protons, electrons, and neutrons, and these only are applicable to an element in a ground state. And then I also said, I think in my first video or second of the sequence video, that if you see that the atomic number tells you the number of protons and electrons, and if you've seen on all the examples we've done, the number of protons and electrons have always remained the same. It's the number of neutrons that's different. Okay, for instance, okay, let me erase this right here and summarize a few things. So hydrogen, if you looked at it, we did hydrogen, we noticed it had 1 proton, 1 electron, and 0 neutron. I remember we also did helium, okay, where we said it's got 2 protons, 2 electrons, and 2 neutrons. Okay, I believe we also did I think vanadium, I believe, and we said it's got 23 protons, 23 electrons, and 28 neutrons. If you see in all these cases, okay, individually, okay, I'm going to draw a box, okay, that's 1 proton, 1 electron, 2 proton, 2 electron, 23 proton, 23 electrons. Okay, in all these cases, each element has its own identity. Okay, just like each of us have a different DNA and a social security number, which is very unique of us. There's only 2 things in the world that's very unique that sets us apart. One is the DNA, and the other is, if you live in the States, it's the social security number, right? Our tax ID number, or our passport number. Things like that are very unique to that person. It can be shared by another person, right? But within each person, each element in this case, the number of protons and electrons have always remained the same. So if it's 2, it's 2, it's 23, 23, 1 means 1. It's just the number of neutrons. I'm going to change it to a different color, perhaps maybe the orange right here, or maybe even a black might work on this white background. See that it is this number of neutrons right here that are different for each element, and I think that's what really makes the element very unique. Okay, now let's take this information and see if we can do a reverse mapping, see if we can figure out the identity of the element, more like a Sherlock Holmes figuring out, doing some investigation. All right, so let's go ahead and delete this up, and let's go ahead and write, say I give you, this is the identity of, predict the element, predict the element. Okay, so if I tell you what is the element given I give you 1 proton, 1 electron, and 0 neutron. What is, if these are the criteria, what does these criteria, what element constitutes these criteria? Okay, so the 1 is a key here. Okay, I'm going to go switch it to a different color, maybe a red. Okay, if you so noticed, I'm actually going to erase this and come back to my pen. If you see, the 1 is what you first look for. It's the number of protons and electrons. 1 means the atomic number is 1. If the element is in a ground state, that's all you really need. You don't need to even worry about how many neutrons it's got, because every element has a unique atomic number. Now you go look at the periodic table and you see that it's hydrogen, because hydrogen is the one with atomic number of 1. And at that point you can actually copy the atomic mass from the periodic table, which is 1.008. But here we're not worried about the figuring out the value, it is the identity. So let's go back and get a different color. So now we know that the number of protons, what's the identity of the element is hydrogen. Okay, let's do a different exercise based off the same concept.